Hello and welcome to Mr. Linford's presentation on unions and intersections. In this discussion, we're going to be talking about what a union and intersection is and how do we take the union and intersection of different intervals. So to start, let's try to get a working definition of what a union and intersection is. For given sets, A and B. So imagine you're given two sets. You can be given multiple sets, and this happens a lot in the real world. You're given multiple data sets, you're given multiple collections of information, maybe you have multiple equations, inequalities to work with, whatever. But for our example, we're just going to say, assume you're given two different sets, A and B. The union of A and B is the set of elements that are in either A or B. So the union is going to be the set of elements that are in either A or B. And we're going to use this little symbol U to describe it, a capital U. For intersection, we are going to define the intersection as the set of elements, so the set of elements that are common in both A and B. Notice that union really helps us describe a set, and intersection helps us describe a set. Both of these are brand new sets, okay? We're creating brand new sets from two original sets. The union is all of the elements that are in either A or B. And really, if you think about it, I'll try to get a different color here. The union is essentially the set of all numbers. The set of all the elements. So essentially, I want everything in A and B, because that's what I'm saying here. I want all the elements that are in either A or B. So give me all of the elements. And the intersection is really the common elements. So what elements are in A and B together? Which ones do they have in common? And remember, union has this capital U symbol. Intersection has this upside down U symbol. Sometimes students call it a lowercase n. It's really just an upside down capital U. So let's take some time and practice finding unions and intersections of different sets. Here we have the set 1, 2, 3, 4, 5. And here we have the set 2, 4, 6, 8. Let's go ahead and start by taking the union of this set. Well, that means I want all the numbers from the first set and all the numbers from the second set. Well, let's just go ahead and list them. So 1, 2, 2 is in actually both sets. I don't need to relist 2. Same thing with 4. Sets really just need to have the element listed once. We don't ever double list an element. So I've listed 1, 2, 3, 4, 5, and I've made sure to include 6 and 8. I don't need to double list 2 and 4. So this set has every element from the other two sets in it. This set is the union. All right, let's clean some of this up and let's try to find what the intersection now is. Remember, the intersection is the set of elements that are in both of the sets. So what numbers are in both sets 1 and 2? Let's see. 2 is in both, and oh, what do you know? 4 is in both. So the intersection of these sets is going to be 2 and 4. These are the numbers that are in both sets. That makes them the intersection. The union is everything together. I want all of the numbers. Just do me a favor, please don't double list any numbers. Okay, so the last example, not that bad. But let's try to get into one that deals with intervals. The best way of working with intervals is to try, and because we're really going to have to visualize this, is to make a number line. So I always like to make a number line. And I'll put all the numbers on there, 0, 2, 5, and 7. I'll put all the numbers that I have in the intervals. What we're going to do here is we're going to graph each one of these intervals on the number line. And I'm going to use a different set of colors for them. So I'm going to do this interval in blue. So we're going to go from 0 to 5. So I want all the numbers between 0 and 5, and I'm going to include 0 and 5. So I'm going to put brackets around them. For the next interval, 2, 7, let's go ahead and use green, and let's see if this helps us out. So 2 all the way up to 7, and I'm going to include both 2 and 7. So let's take a look at this, and let's start to see what's the union and what's the intersection. Now the union we said is everything, all the elements. So I want everything from 0 to 5 and from 2 to 7. Well, if we take a look at that, isn't the union then just all of the numbers in between 0 and 7? Isn't it just all of these numbers, every single one in between? So hopefully that's looking kind of obvious to you, but a big key part here is just looking at these graphs that we drew. I think these graphs are going to help us out. So just look at where did you start and where did you end. And that helps determine that the union is everything from 0 to 7. And since we have these brackets on 0 and 7, go ahead and include them. We know we're good with that. Okay, let's try this again, but this time let's try to find the intersection. Well, it should be pretty obvious that the intersection is where the graphs overlap. That's where all of the elements are the same in both. These are the common elements in both of them. So where the two graphs overlap, that's the intersection, so everything between 2 and 5. We can see that, yeah, both of these intervals have the same numbers between 2 and 5. But now the question is, do we include 2? Do we include 5? Well, 2 and 5, 5 is in the green set, and it's in the blue set, so we're going to include it. And 2, it's in the blue set, and it's in the green set, so we'll go ahead and include that as well. 2 and 5 are in both of these sets, so we're going to include them, and that makes our intersection. The big takeaway from this is the union is everything. Graph the inequalities, or graph the intervals, and you'll see the union is everything from the lowest end to the highest end, every number that's covered by one of these green or blue lines. The intersection is where the two lines overlap. That is the best way of visualizing union and intersection. Let's go ahead and try another example. This time we're going to draw a number line, but I think you're going to see where the difference might be. So let's put on a 0, a 2, a 5, and a 7. I'm going to graph 0, 5 in blue, and I'm going to put parentheses around it and graph, let's get a different color. Let's get maybe a purple or whatever this is called, to graph everything between 2 and 7. Notice these parentheses mean exclusion. We are not including them. So I want everything between 0 and 5 and not including 0 and 5. And I want everything between 2 and 7, not including 2 and 7. So if we're going to go ahead and determine what the union is and what the intersection is, let's do a similar method to before. The union is we want everything from the lowest bound to the highest bound, every number that's covered. Well, all of these numbers are covered, everything between 0 and 7. Both sets have essentially all the numbers between 0 and 7 in them. Now some people might be saying, well, what about 2? What about the number 2? 2 is in this set, but it's not in this set. I don't really care about that, actually, because I'm taking the union. The union is, it's either got to be in one or the other. So as long as 2 is in one of the sets, I'm good. I'm going to include it in the union. And then the same thing with 5. Since 5 is here in this set, I'm going to include it. I don't worry that it's not included here. So really, 0 to 7 is the union, and we're going to throw parentheses around this because the union here, 0 is not included, and 7 is not included, so I can't include 0 and 7 in the union. Everything in between, I'm good, since they're in both sets. Now let's take a look at the intersection. The intersection, I'll do this in red. We said that's where the two graphs overlap each other. Where the two graphs overlap. So everything from 2 to 5. Now, do we include 2 and 5? We're not going to include 2 and 5. The reason being, union had a very loose definition. The element had to be in either of the sets. The intersection says you have to have the element in both sets. To be in the intersection, the number 2 has to be in both sets. It's not in this purple set. And 5 is not in this blue set. So we're not going to include them in the intersection. Everything in between, all the numbers in between, 3, 4, 3.5, 4.1, 2.7, whatever, all those numbers are in the intersection, just not 2 and 5. Okay, I hope this video helps out a bit. I hope it's starting to get to be a little more making sense. What I'd like you to do, take some time, work on the next few practice problems together. And then when you're done, there's a little practice for you to continue working on union and intersection. If you need any help, feel free to email me. My email is klinford@wccnet.edu. I will be checking email over the weekend, and I will be in at the end of the day. So if you need any help, please let me know. Until next time, take care.